So in the next couple of examples, we're going to be looking at using identities and then factoring to solve these equations. In this example, we are asked to find all solutions of this equation. So we're asked to find all possible angle solutions for theta. And since we're working with theta, we're going to look for answers in degrees. Now this one's a little bit different because we see that we have sine theta and we have cosecant theta, so we have two different trig functions. And if we were to think about this in terms of the algebra, if we think about sine as being a variable, let's call that x, and cosecant being a variable, let's call that y. If we were asked to solve this in algebra, we would have a hard time doing that because we have two variables and we only have one equation. Solving equations requires that if I have two variables, then I have two equations. If I have only one equation, then I need to have only one variable. So let's think about this. If I go back to the trig equation here, is there a relationship that I can manipulate between sine and cosecant? And the answer is yes. We can actually use the reciprocal identity. So we can write this as sine 2 times sine theta minus 1 equals 1 over sine theta. And if we think back to the algebra now, that looks like this now. 2x minus 1 equals 1 over x. So we have 1 over sine, and we said sine was like x. So now we have this. Well, how would we have solved this in algebra? Well, we want to multiply everything through by x, so that we don't have a variable in our denominator anymore. We're going to do the same thing here. We're going to multiply by the LCD. In other words, we're going to multiply everything through on both sides of this equation by sine theta. That way sine theta is not in the denominator anymore. So we're going to multiply through by sine theta. So we end up with 2 times sine squared theta minus sine theta equals, and then if we think about this as a fraction, we multiply across, we end up getting 1 because those sine thetas will cancel out. So now we have something that looks like 2x squared minus x equals 1. And if I was working in algebra and also working in the trig, I was going to get everything over to one side and then we're going to factor. So let's subtract 1 from both sides. So we have 2 sine squared theta minus sine theta minus 1 equals 0. So we get everything over to one side and then factor. So we have 2 sine theta and then sine theta. So first times the first has to give us the first. And we look at the last, we have minus 1. The only options here are 1 and 1, and we need a plus and we need a minus. So I'm going to put the minus here and the plus here. And let's check it, make sure that if I FOIL it out, I get back the correct middle term. So let's keep going. Now that it's factored, we're going to set each one of these factors equal to 0. Now we have two different linear equations that we want to solve. We're going to subtract 1 from both sides here. So we have sine 2 times sine theta is equal to negative 1. And then divide both sides by 2. We get sine theta is equal to negative 1/2. So we're looking for angles on the unit circle that have a sine value of negative 1/2. So we're looking in quadrants 3 and quadrants 4, where sine is negative. And we know that's our 30-degree reference angle. So we're going to go 30 degrees from the x-axis into quadrant 3 and 4. And that would give us angles of 210 degrees and 330 degrees. Now we're looking for all possible solutions. So that would be theta is equal to 210 degrees plus 360 degrees times n, and also 330 degrees plus 360n. We also want to solve this linear equation, so we're going to add 1 to both sides here. We end up with sine theta is equal to 1. And we're looking on the unit circle here to find where is sine equal to a positive 1, and that would be up here at 90 degrees. So that's the only place on our unit circle that has a sine value of positive 1. So our solution will be theta is equal to 90 degrees plus 360 n. So here we were looking for all possible solutions, so not only the 3 that we found on the unit circle, but then all coterminal solutions, and we do that by adding 360 n to the 3 solutions that we found. So in example 9, we are asked to find all solutions of this equation. 5 plus 5 times tangent squared theta equals 6 secant theta. And here we once again have 2 different trig functions. So if we were solving this in algebra, it would look something like this. 5 plus 5 times, let's say, x squared equals 6 times y. Once again, we run into a problem because we have 2 different variables and we only have one equation. One thing that we could try first is to bring everything over to one side and see if anything will factor. Well, nothing is going to be able to factor out of all 3 of those terms, so that method won't work. The next thing we want to try, if factoring doesn't work, is to try using an identity to get everything to be in the same variable. So what is a relationship between, let's say, tangent and secant? And we want to keep in mind that we do have a tangent squared. And that should sound like a Pythagorean identity. So tangent squared theta plus 1 is equal to secant squared theta, where this is our Pythagorean identity. We want to replace just tangent squared theta with something that is equivalent to it. So let's subtract 1 from both sides. We get that tangent squared theta equals secant squared theta minus 1. So we can replace tangent squared theta with secant squared theta minus 1. So let's do that. Okay. So we're going to bring down the 5 plus 5, and we're replacing tangent squared theta with its equivalent, secant squared theta minus 1. And we're going to bring down everything else. Now we only have one trig function within our equation, and that's what we want. So we're going to get rid of the parentheses by doing a distribution. So now we have 5 plus 5 times secant theta minus 5 equals 6 secant theta. And we notice that we have a 5 and then a minus 5. So these are going to cancel each other out. So now we have 5 secant squared theta is equal to 6 secant theta. Our goal is to get secant theta by itself on one side. So what we're going to do is we're going to subtract. We're going to get 0 by itself on one side, everything else on the other, and then we're going to try to factor. So we're going to bring everything to one side. So we have 5 secant squared theta minus 6 secant squared, or secant theta. There we go. So once everything is in terms of secant only, we're going to try to factor. We're going to bring everything over to one side and then try to factor. Well, what is common between those two terms? They both have secant theta. So let's factor out secant theta. So that's secant theta times 5 secant theta minus 6 equals 0. Now that it's factored, we can set each one of these factors equal to 0. And then we'll have two equations in linear form that we can solve for secant. Okay. Well, the first one is secant theta equals 0. And keep in mind that we may not be familiar with the secant values, but we are familiar with the cosine values, so let's go and let's change this to be the reciprocal function. So the same angle that would have a secant value of 0 would have that same angle would have a cosine value of the reciprocal of that. Well, the reciprocal of 0, if I think about this as over 1, and I flip that fraction, I get 1 over 0. There's no angle that we know about that has a cosine value that is undefined. If we think back to the domain and ranges for secant, what are the allowed output values? Or in other words, the range for secant. Well, secant, those output values go from negative infinity to minus 1, and then from 1 to positive infinity. Let me write that straight. So secant actually never achieves a value of 0. And cosine actually never has an output value that's undefined. So there's no solution to this part of our equation. Okay, so this will not yield a solution. But we might still be able to find a solution from this part. So let's solve for secant. Let's add 6 to both sides. We have 5 secant theta equals 6. Divide both sides by 5. Secant theta equals 6 over 5. Not an angle, not a value for secant that I'm familiar with. So let's change it to be cosine and see if that looks more familiar. So the same angle that has a secant value of 6 over 5, that same angle would have a cosine value of 5 over 6. Well, once again, not familiar with that cosine value. So let's put this into our calculator. Cosine inverse of 5/6 equals what angle? And once again, we want to keep in mind that we are looking in two quadrants for this solution. We are looking in quadrants where cosine is positive, since we're looking for a positive cosine value, which would be quadrants 1 and quadrants 4. So when we put this into our calculator, we're looking for angles in degrees. Let's go ahead and round to the nearest tenth here. And when I put this into my calculator, I get 33.6 degrees. So this will be the reference angle that we end up using. So the distance from the x-axis to the point in quadrant 1, that is a 33.6 degree reference angle. So one of our solutions is 33.6. That's in the allowed interval from 0 to 360 there. And then I'm going to find the same reference angle in quadrant 4. And what we want to know is if this distance is 33.6, what we're actually looking for is if I start at the x-axis and go all the way around and I stop at this point right here, what angle is that? So what quadrant 4 angle starts here and goes all the way around and stops here where we have a reference angle of 33.6? Well, in order to find that, we have almost a complete rotation except we stop 33.6 degrees short of going all the way around the circle. So we stop right here. How would I determine what that angle is? Well, we would have to take 360 degrees and subtract from that 33.6 degree reference angle. So what we actually get then is 326 degrees, 0.4. So we'll round to the nearest tenth. So remember that we want to find all possible angles on the unit circle, and we use reference angles to determine how far into each quadrant that we're going to go from the x-axis. So we're asked to find all possible coterminal solutions to this as well. So for each of these, since they're not equally spaced and are not halfway around the circle from each other, we are going to just add 360 in plus 360 degrees times n. So these will be all possible solutions to this equation. So the two angles that we found on the unit circle plus all possible coterminal solutions to those two angles as well.